You should be on in your workbook on the page that says pHet bending light simulation. I think it says something like that. pHet, pHet bending light simulation. And on that page, you're going to, there's 4 blank boxes. You're going to title the top left refraction, air meets glass. So again, top left box, air, refraction, air meets glass, or air versus glass, something like that. All right, so don't do anything else yet. Just watch what I'm doing. So here you'll see a laser pointer. You see that it's in the air right now, if you see the material above. And the material below is, I've set it as glass. So obviously we know that when I hit this button, there should be some refraction, but also there's going to be some reflection. All right, so I want you to draw this picture of the rays. I want you to draw this in your notebook. And what you should notice, again, is that most of the light, so label this refraction. Okay, so if you need to pause the video, you can. But label this line refraction. But you see some of that light ray splits off and actually reflects. Otherwise, we wouldn't even see the glass. So a little bit reflects so that we can see it and bounces off the surface. But most of it doesn't, it refracts. And what I mean by that is, here's the light. It always wants to go in a straight line. And that's in gas where it can travel really easy. Well, then all of a sudden, boom, the light hits the glass. It slows down. And instead of going in this straight line like my arrow is going in now, it slows down and bends. Okay, so now in that box, I want you to write a sentence of what this picture is showing you. So pause the video if you need to do that. Hopefully your sentence said something like, when the light ray is going through gas, it travels faster, but when it hits the glass, the solid, it slows down so it bends. But at the same time, because it is a surface, they some of the light bounces off, and that allows us to see the glass. Okay, now we're going to go to the second box, and I'm going to switch to what's called prisms. And in the second box on the top right, I want you to label it prism. Okay, and on this one, I'm going to kind of turn it a little bit. I'm going to go into a dark mode over here, so you're going to see me on dark mode. And when I turn this on, we did this experiment. So all this is kind of review of stuff we've done. You'll know that it's going to refract. Okay, so you can see the rainbow down here. If I didn't have it bent perfectly, it's kind of hard to see it, so that's why I had to bend it. But again, you're going to notice that there's some refraction. Okay, so when it goes, here we are in the gas, the light hits the solid surface, slows down and bends, and then when it's coming back out, it's actually refracting back into the gas. So it's bending back out, but now at these different wavelengths. Because remember, colors have different wavelengths. So red up here is a longer wavelength than down here of the indigo. Remember Roy G. Biv, red, orange, yellow, blue, indigo, violet. Red has the longest wavelength, while blue down here is going to have your shortest wavelength. That's how we see color at different wavelengths. Okay, so draw this, draw what's happening, but I'm also do that and then pause the video. Okay, I'm going to assume you've drawn at this point. Now I'm going to introduce reflections, and we're going to add this to our picture. Okay, so I want you to add these lines to our picture, and if you notice, so when light hits an object, if the object has any kind of color, as long as it's not black, it's going to reflect something. Okay, so all these other lines are lighter because they are splitting off from the light ray, and there's not as much of that. So you're going to see back at your eye some reflection, and if somebody was down here, they would see some of the light. That's why we say be careful when you're like shining the prism, because it ends up being in other people's eyes. So if somebody was up at the top, up here, they would see this ray of light. If someone was down here, they'd see this ray of light. And then when you're looking off the distance, you're going to see obviously this rainbow that you're looking for. So again, pause the video, write a sentence about what's happening here. So hopefully your sentence said something about the refraction going through the prism, slows down, the light ray slows down as it hits a solid and bends to the different frequencies, the different wavelengths of the colors of the rainbow. But also, of course, because it is this solid object that's not black, it is going to reflect into different directions as it bounces through the different angles of the triangular prism. Okay, so that's, now we're going to go to the bottom left box, and we're going to go back over lenses. And if you remember, this is called a convex lens. So I want you to title the bottom left box convex lenses. So this is just a review. So again, this time I'm actually going to do multiple rays so you can see it better. But if you remember, this lens really, depending on how thick it was, really helped us magnify things because of how the rays were hitting and refracting off this thickness. So the thicker it was, the more solid material the light had to go through, and it would slow down more and more. So as I turn this on, draw this picture. This is showing just refraction, but you can see the light waves don't focus till you're way over here. So everything up here looks a lot bigger because you don't focus till over here. Okay. And then why do they spread out like this? Well, remember, light travels in straight lines unless it's as it comes back out, this line is crossing and now coming over here. This line over here is crossing and coming back over here, so it spreads back out. So it's like a crossing effect, so that they will continue to go in straight lines. Okay? So draw this and write a sentence. So hopefully in your sentence you mentioned again about the light rays going through gas, but as soon as it hits this curved solid, it slows down, and every light wave ends up crossing each other so that you hit this focal point on the other side and everything is magnified. I am going to turn on reflection so you can see it. This gets kind of crazy, but you should add some lines for reflection because obviously there are some lines. But again, you can see how they're kind of crossing. Even the reflection lines are kind of crossing there. So I would just draw a few lines. It doesn't have to be perfectly like this, but there is going to be some reflection off of both sides of the surface. Okay. All right, the bottom right box is for you to do. Okay, so we call it free choice. So I want you to go to this website that's up here, and it's also in Edmodo. It's really long, so that's why I'm going to put it in Edmodo for you. But this is it right here if you don't want to go into Edmodo, and it's long, so I'm going to you might want to write it down, pause and write it down. Okay. But this is your free choice, but whatever you do free choice, you better understand what's going on because you have to do a sentence explanation underneath your picture. So you can play around with the prisms. There's some more tools you can even play around with that are kind of craziness. And you can go, the intro is probably not going to do too much with you unless you go into like wave mode or something like that. And you can kind of see it going through a wave. But anyway, there's lots of things you can do here. But whatever you pick for free choice, you need to be able to explain it.